So we're going to use linear algebra to analyze a network. Now I have a diagram here of a network, and you can think of this as, say we've got one-way streets, and this is traffic flow through these streets, and we know what's coming in to certain intersections and what's coming out of certain intersections, but we don't know what's going on inside. So we have these unknown uh, constants here, and we want to figure out what those are. So we're going to assume that cars are not created or destroyed, right, when we go through an intersection. So we'll conserve the number of cars. So that gives us a way to come up with an equation that involves these variables. So for the intersection A, I know that what's going into the intersection must equal what's coming out, right? Conservation. So what's coming into the intersection, the arrows say that x1's going in and 400's going in. So x1 plus 400 must equal what's coming out. What's coming out is x2 and 100. So this must be equal to x2 plus 100. Now, when you're solving a system, you want all your variables on one side and all your constants on the other. So I'm just going to go ahead and, change this to standard form. I'm going to move the x2 to the left, move the 400 to the right, and I get this equation in standard form. All right, so for intersection B, we'll do the same thing. So what's going in is x3 plus 200. And what's coming out is x1 plus 600. And I'm going to move the x1 to the left and this 200 to the right. So negative x1 plus x3 equals 400. And for intersection C, what's going in is x2 plus 50. What's coming out is x4 plus 150. The arrows show you the direction. And I'm going to move the x4 to the left. I'm going to move the 50 to the right, and I get this equation. So it's got one more to go. Intersection D. What's going in? X4 plus 300 is going to equal what's coming out. What's coming out is x3 plus 100. And then I'll move the x3 to the left. I'll move the 300 to the right, and I have my last equation. So what I want to do is put all these equations that are in standard form into a matrix. So the matrix will have a column for each variable and a column for the constants that we're augmenting. And we'll have a row for each equation. So the first one is x1 minus x2. So that's a 1, negative 1. There's no x3 or x4, and it equals negative 300. So that's the first row. And the second row will be negative 1, 0, 1, 0, and then 400. Row 3 will be 0, 1, 0, negative 1, 100. And then the last one will be 0, 0, negative 1, 1 equals negative 200. Now this would be easy to row reduce by hand because there's so many ones and zeros here, but I used a calculator and I'll write down the reduced matrix 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then I've got negative 1, negative 1, negative 1, 0, augmented with negative 200, 100, 200, and 0. So for the variables that we're trying to find, we have one that's free, the x4 variable. So there's infinitely many solutions here. So I get x1 is x4 minus 200. I get x2 is x4 plus 100. And I get x3 is x4 plus 200. And then x4 is free. It's whatever we want to make it. So let's say I wanted to put a sensor down to count the number of cars going through the intersection. Well, based on this, I just need to put one sensor down at x4. If I know x4, then I know the rest. Right? That could save the city some money, maybe. Let's just come up with one example, right? So if x4 was, say, 500, then x3 would be 700, x2 would be 600, and x1 would be 300. Because of this negative sign here, I'm actually, there is a minimum for x4. So x4 can't be anything less than 200. If x4 was 200, then x1 would be 0, but x1 couldn't be a negative number because we're talking about cars through an intersection, right? So, the minimum value that x1 could be would be 0, and that means x4 would have to be at least 200. So let's write that down. So x4 has got to be, I wrote that the wrong way. x4 has got to be at least 200. Well, that means that x1's got to be bigger than 0, but it also has ramifications for x2 and x3. If x4 is at least 200, then x2 is at least 300, and x4 is at least 400. So that's just some different ways to think about the system.